Multiplying and dividing decimals. When working with positive and negative decimals, the rules are the same as integers. When multiplying or dividing two decimals with the same sign, the product is positive. When multiplying or dividing two decimals with different signs, the product is negative. When multiplying or dividing several decimals with different signs, count the number of negatives. An even amount of negative signs will be a positive product, while an odd amount of negatives will yield a negative product. If you know how to multiply integers, then you can multiply decimals. Just follow these few steps. Step 1, ignore the decimal points. Step 2, multiply the numbers using the same rules as integers. Step 3, count the total number of digits to the right of the decimal points in both numbers. Put that many digits to the right of the decimal point in your answer. In the problem below, notice that there are 2 digits to the right of the decimal point in each factor. The total number of digits to the right of the decimal points in the problem, i.e. in the factors, tells us how many digits should be to the right of the decimal point in the answer. Since there are 4 digits combined to the right of the decimal points in our factors here, there should be 4 digits to the right of the decimal point in the product. Let's try multiplying 23.2 and 4.04. First, we set the problem up vertically. Then we ignore the decimals and just multiply the numbers. So we start here with this 4. 4 times 2 is 8. 4 times 3 is 12, so we put the 2, carry the 1. 4 times 2 is 8, plus 1 is 9. We put a 0 and we keep going. 0 times 2 is 0. 0 times 3 is 0. 0 times 2 is 0. Put 2 zeros. Keep going. 4 times 2 is 8. 4 times 3 is 12. 4 times 2 is 8. Plus 1 is 9. Then we add them up. 8, 2. That's 17. Carry the 1, 3, 9. There's 1, 2, 3 numbers to the right of the decimal points. So we put the decimal here. The answer is 93.728. All right, so here you can see they did the multiplication and they added all the numbers together, ignoring the decimal points. Finally, count the decimal places in the original problem and place your new decimal point in the product. So you can see that the answer is 93.728. Let's do some practice problems. All right, here we're going to start with the 1. 1 times 2 is 2. 1 times 1 is 1. 1 times 5 is 5. 1 times 4 is 4. 1 times 1 is 1. Put a 0. Keep going. 2 times 2 is 4. 2 times 1 is 2. 2 times 5 is 10. Carry the 1. 2 times 4 is 8 plus 1 is 9. 2 times 1, 2. All right, we'll put 2 zeros. Keep going. 4 times 2 is 8. 4 times 1 is 4. 4 times 5 is 20. Put a 0. Carry the 2. 4 times 4 is 16. 17, 18. Carry the 1. 4 times 1 is 4 plus 1 is 5. Now we add 2, 5. Here we have 15, carry the 1, 5, 4 is 9, 10, carry the 1, 11, carry the 1, 6. Now we go in 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. The answer is 61.09552. All right, let's do the next one. 8 times 1 is 8. 8 times 3 is 24. 8 times 8 is 64. 65, 66. Put a 0. Keep going. Just zeros. All right, put 2 zeros. Once again, just 3 more zeros. All right. Then we put 3 zeros. 1 times 1 is 1. 1 times 3 is 3. 1 times 8 is 8. Add them up. We get 8, 4, 6, 7, 3, 8. And we have 1, 2, 3, 4, 5 numbers to the right of the decimal. 1, 2, 3, 4, 5. The answer is 8.37648. All right, next. 2 times 5 is 10. Carry the 1. 2 times 4 is 8, 9. 2 times 0 is 0, 0, 14. Put a 0, keep going. 5 times 5 is 25. Carry the 2. 22. carry the 2, 0, but there's the 2 there, and then 0, and then 5 times 7 is 35. Add them all together, we get 0, 14, 3, 2, 4, 6, 3. Finally, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The answer is 36.42340. All right, last one. 4 times 4 is 16. 4 times 1 is 4, plus 1 is 5. 4 times 2 is 8. 4 times 3 is 12. Put a 0. 3 times 4 is 12. 3, 4. 3 times 2 is 6. 3 times 3 is 9. And then we just have a bunch of zeros that are going to end up here. So I'm just going to skip that. I'm going to add these numbers together. 6, 7, 12, 3, 9, and 10. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we did need one of those leading zeros there. The answer is 0.0109276. And there you have it, all of the answers. To divide decimals by whole numbers, we're first going to use long division, and then we're just going to bring the decimal up. So just straight up into the quotient. Here's an example. 12.45 divided by 5. First, we're going to set it up like we would any long division problem. You do the division completely ignoring the decimal, and then at the very end, you just bring the decimal up vertically, straight up. A power of 10 refers to numbers that can be written as 10 to the a power, where a is a positive integer exponent. The most commonly used powers of 10 are 10, 100, which is 10 to the second power, and 1,000, which is 10 to the third power. There's a unique property that all decimals have when being multiplied or divided by some power of 10. When you multiply any rational number by 10, it now has a factor of 10. The opposite happens when you divide by 10. You remove a factor of 10 from the number. With decimals, the ultimate effect is that the decimal point moves left or right depending on the operation. The place values the decimal moves depends on the number of zeros in the power of 10 being used. For example, let's multiply 4.28 by 10. When you multiply, the original number will get larger by definition. In the case above, we are multiplying by 10, so the decimal point will move one place to the right. 4.28 times 10 is going to be 42.8. That decimal just moves one spot over. In the case below, we are dividing by another power of 10, 100. When you divide, the original number will get smaller, by definition. In the case above, we are dividing by 100, so the decimal point will move 2 digits to the left. So 567.4 is going to become 5.674.